This is lesson 2-3 on subtracting integers. The objective is to subtract integers and to find the distance on the number line. The Common Core state standards are listed in the mathematical practices. There are some examples on page 63 to 65 in your math book if you'd like to see these examples on a number line. First thing, fill in the box. These are the rules for adding or subtracting integers. To subtract an integer, you're going to add its opposite, then follow the rules for adding integers. So in the first example, I started with a nice easy problem, 7 minus 2, which is 5. But if we look at the box above, it says to subtract an integer, we're going to add its opposite, then follow the rules for addition. So that means that if we keep the 7 the same, change subtraction to addition, take the opposite of the number that follows the subtraction, we should get the same answer. This is the same thing as keep, change, opposite. So what is 7 plus a negative 2? Well, if we take the sign of the larger number, which is positive, and subtract 7 minus 2, we end up with the same answer. So for number 2, we're going to rewrite this. We have negative 7 minus 2. So we're going to keep the first number the same, change subtraction to addition, and take the opposite of the 2, which would be negative 2. So now we're adding, and we have same signs, so we're going to keep the sign, which would be negative because there are two positives, and add. Number 3, rewrite it underneath. You keep the negative 7 the same, subtraction becomes addition, and the opposite of a negative 2 is positive 2. Now follow the rules for addition. We have different signs, so we're going to take the sign of the larger number, that is 7, so it's negative, and subtract 7 minus 2, which gives you 5. So our answer is negative 5. Number 4, 7 minus a negative 2. We keep the 7 the same, subtraction becomes addition, and a negative 2 becomes a positive 2. And 7 plus a 2, same signs, keep the sign and add, we get 9. On the next examples, we're going to just rewrite over our problem. So if we have negative 2 minus a negative 4, we're going to change subtraction to addition and take the opposite of the second number. So now we have 2 plus a positive 4. So we have more positive, so our sign's going to be positive, and we do 4 minus 2, which gives you 2. Number 15. Keep the 15 the same. Subtraction becomes addition, and we take the opposite of the second number. So now we have 15 plus 4, which is 19. Notice in each of the examples, when I change to adding the opposite, I put 2 lines in. It's always going to be 2. You can't just change it to addition. So for number 7, I have 3 numbers. So I keep the first number the same, and I go to my negative, my subtraction. I'm going to change it to adding the opposite. Now I have another subtraction. So I go to my subtraction, I'm going to change it to adding the opposite. Always see that there are 2 lines in between when you change it to adding the opposite. Now going back to lesson 2.2, we can regroup these and add our positives and negatives together. So I'm going to group together my negative 3 plus my negative 8 to give me negative 11. And then I'm going to add 7. Now we follow the rules for addition. We take the sign of the larger number, which would be negative, and subtract 11 minus 7 is 4. So my answer is negative 4. Number 8, 7 minus a negative 11, so I'm going to change it to adding the opposite. And then minus 5, so I'm going to change it to adding the opposite. I'm going to add my first 2 numbers together because they're positive, and I get 18 plus a negative 5. And 18 plus a negative 5, I would take the sign of the larger and subtract, and we get 13. All right, the next 2 examples has absolute value. So we have to do inside the absolute value first, so we have to change the problem to adding the opposite, keep it in the absolute value, follow the rules for addition. So it's same signs, keep the sign and add, so I get negative 22. Now take the absolute value to give you 22. Number 10, the absolute value of 7 minus a negative 6, change it to adding the opposite, rewrite your absolute value, do inside your absolute value first, so 7 plus 6 is 13. Now take the absolute value. All right, if this does not appear 11 and 12 in your notes. You can skip down to the problem solving one. Watch the video for finding distance on a number line. You just don't need to take notes on it. All right, so we're going to find the distance between each pair of numbers on the number line. So we have -10 and 4. So we can, one way of finding it is just graph them on a number line and then count. So we go from -10 to 9, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the distance between -10 and 4 is 14. The other way of doing it is find the absolute value of the difference of the two numbers. Change subtraction to add in the opposite. Same signs, keep the sign and add, and take the absolute value. You still get the same answer, 14. Number 12, -6 we plot, and -5, and count going from -6 to 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Or find the absolute value, -6 minus 5. Change subtraction to adding the opposite. Add with same signs, so -11. Take the absolute value to give you 11. For the last example, it's a problem solving. It says temperature. The highest recorded temperature on Earth was recorded in Africa at 136 degrees Fahrenheit, while the lowest temperature was -129 degrees Fahrenheit in Antarctica. What is the range of the temperatures recorded on Earth? We could draw our number line. We have very large numbers, so we can take the absolute value of the difference between the high score for the high temperature, 136, and the low, -129. Rewrite it to adding the opposite. So subtraction becomes addition. The opposite of -129 is 129. Add that together. So we have 136 plus 129. And we get an absolute value of 265. So now we take the absolute value of it and we get 265 degrees Fahrenheit. So that is the difference between the range of the high and low score.